Let's look at question 79, word search. In that question, you will be given a matrix. In the matrix, you have letters. The letters range is just English, lowercase and uppercase letters. Then you also will be given a string. Your task is to search this string in this matrix. So search this one is very easy implemented by the backtrack algorithm. So first you find some star letter from the word, search in the grid, and then you can imagine this one is the graph. We use the deep first search to do it. So first we can get the grid high, and we get grid wise, and do the loop. We can get the first letter from the word, try it, this one, and if borders letter is this one, we can do the search, right? That we can call the backtrack search. So first we give the whole grid, and we give the which location they are looking now, and for convenience we give the high and wise, and we also can give the words lines, so we do not need to call this function every time. And we can give the currently which index in this word. Okay, so if this function return true, so we are done. Okay, now let us to implement. Okay, if after loop we did not find any solution, return false. So we defined this backtrack function. So we know the first one will be the grid, and the second is x, y, and x, and high, and y's, and the word line, and start. Okay. So first, if word line is equal to start, this means we are done. Return true, right? Else, if y is this if gives the location is inside the grid, and y is less than high, and x bigger than 0, and x is less than y. And this location's value x. So, oh, we forget to bring the word come here. So start here. String word start. Okay. Okay. Now we will go to the next one. So start, and then we have other track function to backtrack function to check it. So this is bird y x h w word line start and the word. Okay, we need 4. So this is 1 and 2, 3, 4. So this one is go to the different line. This is go to the different column. Excuse me. Okay, then return true, return false. Here is something wrong. If we use that way, we'll reuse this location, right? So in that point, we will set this y and x to some special letter, and after they are done, we change this back. So this y is called backtrack. So okay, let's try this one. X Y H word. Which one is that? Okay. Oh, -1. 1 -1. Okay. Okay, and submit it. So look like we are done, right? However, for that one, we can do little optimization. So first optimization I think we can do is before we to run this backtrack to find a solution. First we check, is any letter in this word existent in the board? If not, we do not need to go into the call this function, because we do not go to the last letter in the word. Then we did not find this letter in the whole grid, right? So what we need to do is we can list. We find the first letter location. Here, we do not need it. Here, we can do this later. And first, add y and x. So we just know where it is, and then we try to do the location. Location is we want to count it. So the child side is this is just English letter, right? So we can roughly use that one. And here we know they have this letter, right? And then we check letter in the word. We do this one, and if this one is less than 0, return false. And then we going to each first letter location to do this thing. Okay, so that one will be the 1, 0, and 1. Well, so by this one, we already filled out some situation, and maybe can let the function run more faster. Right, what is wrong? C. Oh, we cannot use this C because this one already used here. So here will be the first C. So is the first C. Okay, try again. Okay, submit it. Yeah, it's much faster. Actually, we can do one more check. So we can create some metrics to check 2 letters, because 2 letters is still in our acceptor range. So even we create the like A, B, C, D, E, F, and we have column also is A, B, C, D. And then we know if we have in the matrix, if we have A is neighborhood, we set as 1. If the AB is neighborhood, we set up this value is 1. And if the AC is neighborhood, so we set up not a neighborhood, we set up 0. So we scan the matrix and build this neighborhood matrix, and then we scan this word to check in the word each 2 letter, closed letter, is in that matrix or not. By this way, we also can improve a lot of. So, but I did not implement this algorithm now, but if you implement, I think this value will be going to the 1 or 2 seconds on this test case. But it's only for the LeetCode test case, right? So in the real world, we can add more check if we think it's good. But the whole idea is still use the backtrack algorithm. So for the time complexity, for that one, this is depends, the first depends how long for the words, and in the worst case, what means for worst case is all letter in the input board is the same letter, and in this word they also is exactly same the letter. So in that one, so you see we need to go into each location, right? So this one will go to the all the in that case. So for the time complexity, so first we need to visit each location, and then in each one in each location, we also need to visit 4 location, and then in the next time, so up, down, left, right, and in the next line, 4, 3, because someone we already used, right? 4, 3, and then depends how length of the word length. So we also need times word length. This is in worst case. For space complexity, that is totally depend on the how long we call the backtrack. So backtrack is the word length. So space complexity is big O of word length. Thank you for watching the video.